Hello everyone, welcome to my chemistry channel BL the short and sweet in chemistry. Now the topic is fundamental concept in organic chemistry for class 11th and 12th. Now it is part 7 where I am going to explain electrometric effect. The question is what is meant by electrometric effect? That is a very temporary effect, it is not a permanent one. And also where the multiple bond existing as double or triple bond. Now, in the presence of attacking reaction, not only multiple bond, but also here attacking reaction is very important. And now the question, what is multiple bond? Multiple bond means more than one bond. If one bond, that is called sigma bond, and if two or three, and that is called double and triple bond. So multiple means double and triple bond. Sigma bond means that is very strong one, and it is head-on-head overlapping is produced, and it is very strong. And if one bond, then it is called single bond, that is called sigma bond. If there is two or three bond, then here the sidewise or lateral overlapping takes place. If two bond, one is sigma, other one is pi bond. If it is triple bond, then one is sigma and two are pi bond. Now the question is here, what is sigma bond and how it is formed? And how it is formed, that means a sigma bond that having head-on-head overlapping, it is px, it is px. So head-on-head overlapping takes place, so it is called sigma bond. Now, if the question, that is three types of sigma bonds, if this one s orbital, that is symmetrical, spherical, and overlapping takes place, that is also head-on-head overlapping. So, it is s overlapping sigma bond. Now, the third one, pxs, that means one is p, other one is s. Px, Py, Pz, no problem because all have same meaning, and now it is overlapping with the s orbital, then it is called sigma bond. Now pi bond means lateral overlapping. There is no direct connection. Pi bond means there is no direct connection. And now what happened? That is called lateral or sidewise overlapping. Example, Py, because Py standing this like this, and see, this is Py and this Py. So when overlapping, there is no direct overlapping, that is sidewise or lateral overlapping, so it is called Py overlapping. Then it is called Pz overlapping. Pz means here you can say that is also sidewise overlapping, so it is pi bond. So if it is see, it is px, it is py, and now when in the middle, here this is called pz. So it is px, py, this is py, pz. All the px, py, pz, the orbitals, they are perpendicular to each other. Now here the electrons, that electrons present in sigma bond, and sigma bond is very strong, so the electrons are attached very strongly in sigma bond. But in case question, electron in pi bond, and here what happened, they are loosely attached, so that is polarized. Polarized means the electron transferred from the polarized electron transferred to where? It is transferred to the more electronegative atom. More electronegative atom, and other thing also, the multiple bond that is attacked reagent. The reagent which can attack here, and that is if you say the pi electron transfer from weak electronegative to strongly electronegative. So what happened here? Here the electron transfer to high electronegative and having also multiple bond, and the multiple bond also attached to attacking reagent. Three conditions: the pi electron can be transferred from a less electronegative to high electronegative, and it is attached by multiple bond having attacking reagent. That means if attacking reagent is present, C carbon and double bond. Now both are same, that is why if the electron transfer from this to this, now it is indication, but here both are having same electronegative carbon. But here AB, where B is the highly electronegative, so pi electron that transfer from here, the 2 pi electron transfer to B, where B is the highly electronegative, that is called A plus and B minus. So here you can understand, if A, B both atoms are there and A is the less electronegative and B is the highly electronegative. Now you can see A and B having double bond, and now the electron transfer towards B. But when the attacking reagent is removed, when added, it gives A plus B minus, because B is highly electronegative. When, see, reverse sign. When reverse sign reaction takes place, when the attacking reagent is removed. When attacking reagent is removed, then again it comes back original position, original state, that is A double bond B. Are you clear? If attacking reagent is added, then the electron transfer from lower electronegative to high electronegative. If attacking reagent is removed, then what happened? It is removed. Then the reaction is reversed and changes to original state. Then electromeric effect represented by E. So how the electromeric that effect is represented by E. Now see, if H plus is added, as a agent, then what happened here? You can observe there is double bond and one side, that is C plus. C plus means carbocation, or you can say carbonium ion is produced, and hydrogen when attached in other side hydrogen is attached, and one side C plus is produced, that is carbonium ion. Electromeric effect conclusion. What is the conclusion of electromeric effect? The conclusion is it should be temporary. Polarization takes place in the multiple bond, and the electron pair moves from lower electronegative to high electronegative with the help of attacking reagent, under the influence of attacking reagent. Then here you can observe what are the types of electromeric effect. You should know the types. The types mean one is positive, other one is negative. Positive electromeric effect, that is plus E. Negative electromeric effect, that is minus E. That means, what is the meaning positive electromeric effect? Positive electromeric effect mean if pi electrons in the multiple bond, from a multiple bond transfer to the atom. That means in positive electromeric effect, you will observe how the transfer of electron takes place. See, where the attacking reagent is attached, that means here transfer which side takes place? Where the attacking reagent is attached. A double bond means one sigma and other one is pi. Two bonds are there. Sigma, that is say strong bond, and pi, that is a weak bond, and its polarization takes place here. The electron cloud, since it is a weak bond, electron cloud of pi bond is very sensitive because it is a weak bond, and here surrounded by the influence of electrophilic symmetry of pi, electron cloud is disturbed. That means since it is very sensitive, the pi electron which are making that pi bond, that is very sensitive, that is very disturbed one. Then what happened? E plus when attached, you can see E plus is attached mean one side, just like I told the hydrogen H plus is attached, and that is also positive electromeric effect. And here also what happened? One side E is attached and other side plus C. C plus means carbonium ion is produced, carbocation ion is produced. Then what happened here? You can observe that means here what is the example? See, the carbon gets negative charge which accept electron pair. There are two carbon in a double bond. One side it takes electron, accept electrons, and here it occupies negative charge, and other one get positive charge. That means that is having what charge? This is the carbonium ion, and other side is negative charge having 2 electrons more. See here, here E is attached here, and minus because the electron transfer from this side to this side, and it is E plus, so it is here attached. Now what happens here? See, examples: CH2 double bond CH2 electrophile, CH2 plus and CH2 minus. And since it is C plus 1, then it is very active also, and it attacks the negative part, it here attacks the positive part. Now if you see that propene means CH3 is electron releasing group, alkyl group is electron releasing group, methyl group is electron releasing group. So the electron forcing towards this CH2, this is the CH2 where electrons are moving by the help of CH3, which is a alkyl radical, that is here plus I effect is more. Now it is H plus, so what happened here? CH plus is produced, that is called secondary carbocation ion. This isopropyl carbocation or carbonium ion. Now if you see what is the help of carbonium ion, and now this is not necessary here. When you see the mechanism part, then only it is one can understand how the mechanism takes place. But here you will see what is that means electrometric effect, that is negative one. Negative means minus E. The pi electrons, again see, because this pi electron is responsible, very sensitive, the electron cloud is disturbed, that is why multiple bonds are transferred to that carbon where attacking reagent does not attach. That means pi electron of the multiple bond just opposite to our positive P plus E. Here where there is no attacking reagent, that side the electron transfer, that is called minus E. So minus E or electrometric effect, here the movement of the transfer of electron takes place where no attacking reagent there. Now see Cn minus, Cn here, Cn minus E, that is cyanide ion having negative charge. Here Cn minus, that is why it is negative electrometric effect. Now we said it will attach because after addition of that is nucleophile and that negative part, here electron is transferred from this to this, and here positive ion is formed, that is carbonium ion, and negative ion is formed. Since you are adding reagent, attacking reagent, there is minus sign, that is why it will attach to this side where positive sign is produced. The positive, due to positive sign here, the Cn group attached here and negative ion produced there as it is. So if you take example, if instead of carbon the oxygen is more electronegative, then what happened? It gives negative charge, that O occupies negative charge. And this, since it is positive, you can write also this is negative charge, and since it is positive charge, that is why immediately Cn comes and attach here. Since here negative charge, that is why it will attach to carbon positive charge, that is called carbonium ion. And now here, now it should be erased. And now what happened here? You should know what is meant by that negative electrometric effect and positive electrometric effect. And now we will see then example in when properly see this one example, that is your ketone group CO double bond, and this side what is the mean carbonyl group you can say here having oxygen, that is a double bond and more electronegative, that is why it is O delta minus. What is meant by delta minus? Delta minus means slightly negative charge, and here slightly positive charge, because oxygen is more. Before example we have seen carbon, carbon. But here this example you can see oxygen is more electronegative than carbon. If you are Cn minus, then what happened? One side also here attach the cyanide ion C as a Cn, and O there is a negative charge, so it occupies negative charge. Then what is difference between inductive effect and electrometric effect? That means inductive effect is a permanent one, whereas electrometric effect is not a permanent one. Inductive effect, attacking reagent not needed. When you will go to inductive effect, where there is no attacking reagent, but in electrometric effect there should be attacking reagent, otherwise no reaction takes place. Now polarization takes place. Where polarization takes place? Polarization takes place where? In our electrometric effect. So what happened here? Partial separation charge in inductive effect takes place. That means delta minus, delta plus, and due to positive inductive effect where electron releasing is more, that is positive inductive effect. When electron releasing capacity is just withdrawing nature and not releasing capacity, there is a withdrawing only, and that is called negative I, negative inductive effect. That means partial separation takes place in our inductive effect, whereas complete separation of charge takes place in electrometric effect. So are you clear? Partial separation, that means here you can write delta plus and delta minus, and the alkyl group releasing electron towards forward, and here you can complete separation, that is in electrometric effect. No ions are formed in inductive effect. You can observe there is no ions because due to only plus I and minus I releasing or withdrawing nature can show the inductive effect, but here ions are formed in electrometric effect. So here electrometric effect takes place. In electrometric ions are formed. So what happens here? In inductive effect no ions are formed, and here so you should erase it, this one, and that is electrometric effect. So I should write as electrometric effect, and again remember no ions are formed in inductive effect and ions are formed in electrometric effect. And till now what you know about the difference between electrometric effect and inductive effect. Similarly, so many points are there where we should know what is the difference between electrometric and inductive effect. See, multiple bonds are not essential. That means double, triple bond are not essential in our inductive, whereas what happened? Whereas multiple bonds, then here applicable to electrometric effect. In electrometric effect, one should know that yes, it is required multiple bonds, and in inductive effect not required any multiple bonds. Single bond contains in inductive effect only because CH3, CH2, CH2, Cl. If this is type of compounds, only you can observe here only single bond, that is sigma bonds are there in inductive effect. Whereas double or triple bond, here what happened? These are must required in electrometric effect. Sigma bond only responsible for inductive effect, whereas pi bond either in double or triple bond are necessary, that is having importance in our electrometric effect. In inductive effect, molecule is exposed to the attack of electrophilic reagent. That means here only electrophilic. What is meant by electrophile? Electrophile means electron loving. Electron loving means which will love electron. Electron is negative charge. Electrophile means which will love negative charge. That means here who? That means plus. So it will attack, plus means nucleus. It will attack. So electrophilic reagent is responsible, is required inductive effect to be exposed. Whereas just opposite in our electrometric effect takes place under the influence of substituent electron withdrawing and electron donating group linked to the terminal carbon atom. Electrometric effect takes place where the substituents electron withdrawing or electron what is my electron withdrawing? That means which will lose electron, the negative one, and electron donating mean which is releasing group. So here what happened? This is responsible. The inductive effect molecule is exposed to the attack of electrophilic reagent, and whereas in electrometric the substituents very important withdrawing and electron donating nature, that one was influenced. So I hope it is clear to all. Though it is a very difficult one, but I hope you clear this one, you understand this one, and you can apply in our organic mechanism and organic reaction wherever necessary. Thanks for watching my video. I hope you will subscribe my channel BL Das Short and Sweet in Chemistry.